Okay, so you did this task really well. The only thing that I'll feed back to you is the extra challenge question and the equation for the extraction of sodium from sodium chloride by electrolysis. Um, Pretty much all of you got the equation, right? So you start off with sodium chloride, solid, all right, and then you do electrolysis on it, and you get sodium and chlorine, right? But chlorine comes off as a gas, so you have to remember that chlorine is a diatomic molecule, right? And then you have to make sure that it's balanced, right? So you can balance it in the normal way of making two chlorines over here and then two sodiums over there. And as far as the equations are concerned, sodium at room temperature would be a solid, all right, and chlorine at room temperature would be a gas. So you can put those state symbols in there. Lots of you got that equation right. Some of you didn't get the chlorine molecule as a diatomic molecule, and others of you didn't do the balancing correctly. But nevertheless, it was attempted quite well. The other thing I would say is that what we should note is that you have to do this with molten sodium chloride. Molten sodium chloride. If you do it with so molten sodium chloride, let's call that sodium chloride liquid. If you do that with sodium chloride solution, right, then you're not going to get sodium. You're going to get hydrogen. All right, so let's write that up here just to remind you. So not aqueous sodium chloride. All right, why? Because with aqueous sodium hydroxide, you're going to get hydrogen gas coming off the cathode instead of sodium. All right, and we want sodium. All right, so if you do it just molten sodium chloride, you've got no water molecules there, so there's no hydrogen there to come off, and so that's why. Okay, thank you very much.